superposition. So before understanding the principle of superposition, what we have discussed in the last two lectures, first of all we have studied the Coulomb law in vector form, and then after we use that formula in numerical, and so we can understand how can we find the forces between two charges. Clear? So in that we don't have to find problem because in the magnitude we really did it. Clear? But now what we have the situation, if there are two or more than two charges are there, clear? And literally we need more than two charges. Then if there are more than two charges or the 3, 4 n number of charges are there, and you are supposed to find a force on an individual single charge particle, then how can we manage that one? So for that we need a principle of superposition. Principle of superposition you have already dealt with the 11th standard in the wave chapter. Clear? Where we studied that when two or more than two waves are superimposing on a single point, then how can we calculate that amplitude of single particle? By vector addition. Clear? So here we are going to do the same thing. Here we have considered 4 charges. So first of all we will deal with the 4 charges, and after the 4 charges we will take it for the n charges also. So in my case I have considered the 4 selected charges Q1, Q2, Q3 and Q4. So here we have 4 charges, and on one, these all 3 left charges are going to exert a force, and we are going to find out how much force is exerted by that 3 on one. Clear? So I will consider here that on charge Q2, how much force is going to be exerted, net force I want to find out by Q1, by Q3 and by Q4. Clear? So for that, what we need of this principle of superposition. So before that, we will explain geometry of the figure. What is that we have considered? So here we have considered that as shown in figure, the charges are Q1, Q2, Q3, Q4 having the position vector R1, R2, R3 and R4 respectively in Cartesian system. Now, we are supposed to find the force on 2 net force, but we will first find out the individual forces by Q1, by Q3 and by Q4. And then we will do the vector addition of this one, all forces. So that is called the principle of superposition. So principle of superposition actually is like that when you do the vector addition of any physical quantity, so that will be the correct answer. So here we will find out the total force on Q2 by Q1, Q3 and Q4. Clear? So first of all, I start with the force on 2 by 1. Clear? So my first one is the force on charge Q2 by charge Q1, and that we can know that represented by F21, that is force on 2 by 1. So F21 we know very well something derived by the Coulomb law. So F21 equals to K Q1 Q2 by R21 the whole square into direction R21. This is showing the direction and this is the magnitude. Clear? We know by the Coulomb law vector form. Similarly, that force on 2 by 3 and force on 2 by 4 can be written like this way. Force on 2 by 3, that is K Q2 Q3, R23 magnitude square and R23 the direction. F24 the force on 2 by 4, that is K Q2 Q4 R24 the magnitude square and R24 root, that is showing the direction. So here we have equation 1, 2 and 3, which shows the force on 2 by 3 and 4 and 1. So that's all 3 individual forces which is exerted. Here I found the direction also. The force on Q2 is acting in this direction by the Q3. The force on 2 by 1 is in this direction, and the force on 2 by 4 is in this direction. So we have to do the vector sum. So by the vector sum we can get the magnitude also, and then after we get the resultant direction also, in which direction that Q2 is going to experience that force. Clear? So after having this equation 1, 2 and 3, now it's time to apply the principle of superposition, which will use the net force. So here we have mentioned it, according to principle of superposition, the net force on charge Q2 is F2, and to get the F2, what we need to do, as I said, you vector addition. So vector addition, that means we already found it, F21 we found it here, so that F21 plus F23 from here, and last F24. So individually you found that all these 3 forces, now we do vector addition. So by vector addition, putting the value, what you have F21, that is K Q1 Q2 by R21 the whole square R21, that's when you place. This value is K Q2 Q3 R23 magnitude square R23 root direction, that is placed. F24 value is in place here, from here K Q2 Q4 R24 magnitude square R24 root So now, among all these three terms, we have A, Q2 common. Among all these three terms, what we have A in each term and Q2 in each term. So that we are taken as common. Clear? What is that? Inside Q1 by R21 magnitude square and the direction. Q3 R23 magnitude square R23 group direction. Q4 R24 magnitude square R24 group direction. So that is last. Okay. Now, if you are supposed to given value of these charges and you know how to deal with this magnitude also, and you know how to deal with the direction also. I mentioned in earlier lectures that when we are just taking the vector equations of direction, we need to be very careful because x component can be calculated together, y component and z component can be calculated together. No x y, no y z, no z x can be calculated together. So they are separated. So x component separately you calculate, y separately, and the z. In a Cartesian form also you can write it, or in the putdowns of particular I, j, and k rule. Clear? So that are written in the form here. This is the summation now. This is the addition. So what we can do that we have to take it to outside. We have to do the summation of this term which we have. Clear? So what is that in way written? That's Qj. So your j must be from 1 to 4. J must be from 1 to 4 except 2. You are not supposed to take the 2. Clear? Because 2 is here. So charge 2 is not exert a force on itself. Clear? So 2 except 2 you have to leave. And after that R2j magnitude square R2j root. So entire system can be represented in that form. Clear? Or further you can just expand it, take you to summation again j equals to 1 to 4 except 2. 2 you cannot include it. Clear? Qj, here all the values for j will be there from 1 to 4 except 2. R2 minus Rj. So here for j 1 to 4 all values except 2. R2 minus Rj except 2 all the values from 1 to 4 you can take. This will show you the direction. This will give you the magnitude. And that net value of the force you will get it from the magnitude, and this is showing the direction. In which direction this force is exerted by all the rest three on charge Q2. So this is the principle of superposition. It is very beneficial because we have multiple charges in the system. So when it comes to multiple charges of system, it is very congested to sort out how to get the force on individuals. So by using the principle of superposition, it can be calculated easily. In the future also we will have electric field, which is a vector quantity. So there are more than charges, so obviously electric fields are more. So on that basis we need the principle of superposition. So from now on, whenever the vector additions we did it, everywhere we need to got the principle of superposition. Clear? So last and final, these are considered, as I say, is the 4 charges. If there are more than 4 charges, if there are n number of charges are there, then also this principle is useful and quite easy handling. So in a general, for the n number of charges we have, in general for the system of n charges, what we have, suppose if there is one of the charges, I charge, on that I am finding the force Fi. So that is the charge on which I am finding the net force. So that will become K2y. K is constant that will come out from all the terms, and Qy, that is the charge on which we are finding the force, net force by the rest of the n particles. So K2y come out, summation. What do you take the summation? Summation of Qj. J is going to be from 1 to n, all that values except I. That's when we have to leave it. Again, Rij, the whole square, and Rij, the root. Again, this you can write in this form also, that summation of j to 1 by n, and j is not equal to I, then you have to take that Ri minus Rj, the magnitude square, into Ri minus Rj, the unit vector direction. So that will show you the direction. So this principle of superposition is very handy when it comes to multiple charges to find out the net force on any individual force. Still, if you have any kind of confusion on applying this principle of superposition, you can ask me. And for getting better ideas for this one, try to solve numericals related to this one. When there is multiple charges are given to you, 3, 4, 5, or n number of charges are given to you, try to apply this principle of superposition so you can get an idea that where you are getting the point or not.